Hey everyone, and welcome. Today we're tackling a Leetcode problem called maximum difference between even and odd frequency y. It sounds a little complicated, but don't worry. We're going to break it down into simple, easy to understand steps. Alright, so here's the task. We're given a string of lowercase English letters. Our goal is to find two characters in this string. The first character, let's call it a 1, must appear an odd number of times. The second character, a 2, must appear an even number of times. We want to find the pair that gives us the biggest possible difference when we subtract the frequency of a 2 from the frequency of a 1. Let's walk through an example. Imagine our string is A, B, B, C. First things first, let's count the characters. The character A appears 5 times. That's an odd number. The character B appears twice. That's an even number. And C appears just once, which is also an odd number. Now we need to pick one character with an odd frequency and one with an even one to make the difference as big as possible. To get a big result from a subtraction, you want to start with a large number and subtract a small number, right? So we look for the largest odd frequency we have. That's 5 from the character A. Then, we look for the smallest even frequency. That's 2 from the character B. The maximum difference is simply 5 minus 2, which gives us 3. The key insight here is really simple when you think about it. We want to maximize a subtraction. The best way to do that is to make the first number as big as you can and the second number as small as you can. The problem gives us two rules. The first number has to be an odd frequency, and the second one has to be an even frequency. So our whole strategy boils down to this. We'll look at all the character counts in the string. We'll find the absolute biggest number that's odd, and the absolute smallest number that's even. Then we just subtract them. So how do we actually build this in code? It's a two-step process. First, we need to count up all the characters. The easiest way is to use something like a hash map, where the key is the character and the value is its count. We'll just loop through the input string once to fill this map. Second, once we have all our counts, we'll loop through those counts to find our two magic numbers. We'll have a variable, let's call it max odd, that keeps track of the biggest odd number we've seen, and another variable, min even, for the smallest even number. We initialize min even to something huge, so that the very first even number we see will definitely be smaller. After checking all the frequencies, we just subtract min even from max odd to get our answer. Alright, here's the complete solution in Python. I know seeing a block of code can be a bit much, but don't worry. We're going to walk through each part nice and slowly, so it all makes perfect sense. First up, we handle the counting. Python has a really handy tool called counter from the collections library that does this for us in one line. When we give it our string s, it automatically creates a map-like object where keys are the characters and values are their frequencies. Super efficient. Okay, this is the core logic. First, we set up our variables. We start max odd at 0, because frequencies can't be negative. We start min even at infinity, which is just a computer's way of saying a really big number. This guarantees that the first even frequency we find will become our new min even. Then, we loop through all the frequency values we counted earlier. For each frequency, we check if it's odd or even. If the number is odd, we compare it to our current max odd and keep whichever one is larger. If the number is even, we compare it to our current min even and keep whichever one is smaller. By the end of the loop, these two variables will hold exactly the numbers we're looking for. And finally, the easy part. After our loop is finished, and we've found our maximum odd frequency and our minimum even frequency, we just subtract them. The problem statement implies that we will always be able to find at least one character with an odd count and one with an even count. So, we can confidently return the difference between the max odd and min even values we found. So, how efficient is our solution? It's really fast. For time, the main work is looping through the input string once to count the characters. So, we say the time it takes is directly proportional to the length of the string, which we call big O of n. The second loop, over the frequencies, runs at most 26 times, which is a constant, so it doesn't really affect the overall time for large strings. For space, we use a map to store the counts, but since the problem uses only lowercase English letters, there are at most 26 unique characters. This means our map will never grow beyond 26 entries. That's a fixed, constant amount of memory, so we call it big O of one space. So, to wrap it all up, what are the key things to remember from this problem? First, when you see a phrase like maximum difference, immediately think about how to make the first part of the subtraction huge and the second part tiny. Second, This problem, like many others, boils down to just counting things. A hash map or a simple array is your best friend for frequency counting tasks. And finally, we saw that a single efficient pass through our collected data was all it took to find the answer. No complex algorithms needed, just a clear, simple plan. And that's it. I hope this explanation made the problem feel much more approachable. If this video helped you out, I'd really appreciate it if you hit the like button, subscribe for more tutorials, or leave a comment with any questions. And hey, if you're feeling extra generous, there's always the Boba Fund. Thanks for watching, keep up the great work, and I'll see you in the next one. Happy coding!